Okay, so part 2 then asks us to find the angle OAB, so this angle up here. In order to find angle OAB, we, the equation, the cos of any angle is the dot product of the two vectors. So the two vectors we're going to need are minus A with A to B, or A to O dotted with A to B, over the magnitude of those two vectors. Or the product of the magnitude. Okay, so we just need to find, we've got this already. We've got the magnitude of A to B. That was the root of 161. We found that in part A. So we need the magnitude of A to O, which is just the magnitude of this vector here. The vector A to O, which is just the negative of this, A to O, is going to be -4, -3, +2. And then use that with the dot product of A to B, which we also found out in part 1. To complete everything we need for the equation. So A to B was -11 to 6. -11 to 6. The magnitude of A to O is going to be 16 plus 9 plus 4 square rooted, so that's the root of 29. So we've got the two magnitudes now. We've got A to O and A to B, and we are going to do the dot product of these two vectors to get this top part. So the dot product, A to O dotted with A to B, is -4 times -11, so that's +144, -3 times -2, so that's take away 6, and +12. So that will be 50. Okay, so therefore the cos of the angle that we're looking for is 50 divided by the root of 29 times by the root of 161. So if I type that into my calculator and find the inverse cos, I'm in degrees. You can be in degrees or radians, it doesn't matter for this question, I don't think, but I'll check that in a second. Inverse cos gives me 42.96, so 43.0 degrees.